So we will go to the major important topic for today, entity relationships. So we will take some half an hour for that. So shall we proceed to that? ER model. So I would take it in some slight detail because that is like some way in which database design, if you are doing at any time of your jobs or any course, or if you are trying to interpret or find how a database is implemented, data relationship diagrams will be something that will come very handy to you. So we will just see that in a little more detail. So we will okay, no issues. Once you go through this material, you will get a more idea. No issues. Okay, so basically, I want you to keep your minds fresh. This is like you approach this like a fully new topic. Like forget everything that we learned just now. Assume like this is a new topic you are learning. So we will start with entity relationship model. So the data model that we saw in last class, first model that we discussed was relational model. And today we will discuss what is called the entity relationship model or ER model. So this was introduced by Peter Chen in 1976. And it was initially intended as like a graphical representation of the entities and their relationships. But it later became very popular because it was very easy to use the entity relationship model along with the relational data model to actually design and implement databases. And this is actually a high-level conceptual data model, and it allows us to describe the data in terms of objects and their relationships in a graphical way. Like with diagrams, I can represent what I need to implement in a database. And ER models are represented in what is that graphical representation is called ER diagram, and which uses graphical representation to model database components. So I'll just tell what entity and all are. Then I will directly move to a sample entity relationship diagram, and I will tell you how you can interpret that or how you can draw that. If you are more interested in the theory, I have put 2-3 slides in between, so you can go through that to get more idea. I will directly jump to an example and explain with you how that arrived, and then maybe we can try to see one more example where we can try to develop something like an ER diagram. So basically, it models an enterprise as a collection of entities and relationships, where entity means that a object, so anything like a course or teacher or subject, university, all those anything that can be modeled as a subject is called an entity. And a relationship is an association between entities, like a teacher teaches a course or student enrolls for a course, like that. So that enrolls or teaches will come under a relationship. So ER model basically employs the entity sets, that is a list of entities, relationship sets, that is a list of relationships, and attributes that are like if I am a student, I will have a student ID, name, mobile number, things like that. If I am a professor, I will have maybe my qualification, my years of experience, like that. And relationship may also have some attributes like if I am enrolling for a course, then when the course started, things like that. So I will not go into much details. You can go through. I will just go to an example directly, and I will try to explain with that. Yeah. Okay. So basically, when you draw an ER diagram, this is I have just highlighted the different notations that you will come across. A square box stands for entity. A diamond stands for relationship. An oval box stands for an attribute. This is like similar to our column name that we saw in our relation, if you consider. And there is a concept called cardinality, like how many entities can participate in a relation. Like if I am having telling like a professor teaches a class, then corresponding to each professor class, there can be like 30 students in the class or 40 students. And corresponding to each class, there can be only one teacher teaching at a time. So I can tell that there is only one teacher who is taking a class to maybe 30 students or 40 students. So that way I want to tell how many people are actually involved in a relation. So that is actually what is called cardinality. And cardinality, there are different ways to represent, like whether it is 0 or 1 or exactly 1. then that will come to our maybe if you consider the professor side. And if you consider the student side, it can be many, 0 or many, 1 or many, that kind of way. Some relations for some courses may be offered in only some semesters. So that will come in the 0 or many. Like either that course may or may not be offered in a particular semester, things like that. Now we will see an example and I will try to explain to you that will be like more clear to you. Now let's consider the case between a doctor and a patient. So my entities here, if you see, are these boxes. One is doctor, one is patient, and we will see that first, and when we'll come to other parts. So we will see that this N here is denotes the cardinality. So what it means that any doctor can have many number of patients, and any patient can have many number of doctors, right? Because a doctor may be seeing 100 patients in a day, whereas a patient may be seeing going to a hospital, maybe seeing a general physician first, then he may be referred to an ENT doctor, then to maybe another surgeon. So things like that, a patient can be seen by multiple doctors. So this relationship is actually many to many. That is, any doctor can have many patients and any patient can have many doctors. And this diamond in between is the relationship a doctor has a patient, or other way patient has a doctor. So now coming to attributes, the doctor's attributes are ID. So ID is primary key. So primary key is usually denoted, attributes are denoted inside ovals, and primary key is usually denoted with an underline. So ID is a primary key, then maybe first name, last name. So this is actually one way of representing it, but actually there is another way, because suppose I have a single attribute called the name, and then I mapped my first name and last name to that. This is also a valid way to represent this. So this is actually called derived attributes in this first name and last name, or composite attributes. Like name is composed of first name and last name. And coming to patient, patient also will have an ID, first name, last name. Then if he is an insurance, he'll be having an insurance number. Then coming to doctor, a doctor has a specialization, right? So we can tell that a single doctor can have many number of specializations. But the if a PH or some DNB or MD, so one MD can correspond to one doctor only. Like two doctors cannot share the same MD degree, right? So that way, each specialization will have only one doctor at the other end, because like similar to degree, one MD degree cannot be shared by two doctors, whereas in any 10 number or 100 number, 1000 number, lakhs of doctors can have the MD degree. So that way, this doctor side cardinality is 1 and the specialization side cardinality is n. So specialization again, ID is the primary key. There can be a description. And a patient may be having some disease. So he may be diagnosed with some disease. So that is the entity in this case. And again, same case, a patient can be diagnosed with many diseases, whereas the diseases are corresponding to that particular patient alone. If one person is having one disease, it does not mean that another person will be having that same disease. So that way, it is cardinality is again 1 on the patient side and n on the diagnosed side. And in this case, the code can be primary key. In addition, we will have the details table. So this is one way of representing an ER diagram. And this is something that you will mostly see in literature. This is what is called the Chen notation for the actual proposal Chen. Now there is another notation called crossfoot notation. So actually this name came because when small kids draw crow, they will draw a crossfoot like this, right? So from that only this name came, because in this we will be representing many side of the cardinality relationships by this symbol, similar to crossfoot. So that is why this name came. So this is another representation that you will commonly encounter in literature. So let's try to see maybe a subset of this. Maybe this first left half only we will see. So suppose there's an employee. So in this case, earlier we were representing like this entity, when we were representing attributes like this. So in this case, as you can see, the table names are or objects are represented here, and the entities are represented inside that, and the primary keys are mapped with a asterisk, or even you can put an underline similar to other case. And the numbers or cardinalities, instead of m and n in this case, it is mapped with the symbols like what we saw in the earlier slide. This slide, so similar kind of symbols are used to map the. We will just try to read this ER diagram, so that way you will be like clear how you can read an ER diagram. So we can tell that there's an employee, he will be having a name and a manager, and corresponding to each employee there will be a manager, right? That is why this side there is 1, this side 0 or n. So that means corresponding to each manager, there may be 0 or more employees. That suppose somebody is newly promoted as a manager and not yet allotted to an employee, he will not be having any employees under him. But any employee will definitely have a manager. So that is why this side it is 1. Similarly, an employee, suppose he is taking a class. So similarly one employee can take 0 or more classes, and similarly each class can have 0 or more instructor. And this side, if you see cardinality, each class can have 0 or more enrollments. Similarly, each employee can have 0 or more enrollments. So basically, with these symbols, you can read any database schema, which will be usually represented as an ER diagram. And all these are represented using the same diagram, 0 or more. So okay. So I hope you got an idea like how to read the ER diagram. So how we are like drawing this like maybe out of scope in our case. So later when we get some more time in some session, we can cover that also. So I think any doubts in how to read the ER diagram? Then we will just go through the concept of keys, and then we will wind up the session. So basically, when we saw a relational diagram as well as entity relationship diagram, we discussed about keys, right? So we will just see what keys are, and we will wind up today's session at that point. And starting from like normalization, we will start on the next day. And the entity relationship model, if you need some more detailed things, we can cover that also in the next session.